Hello and welcome everyone to the first lecture from the lecture series called Statistics for Dummies. And I specifically created this lecture series to help people who are pretty new to statistics at the MBA level or the economics graduation level. And I understand 100% why it's so tough when you encounter new topics because probably in school you've learned how to calculate mean, median, mode, and probably done a bit of descriptive statistics. But inferential statistics has never been a cup of tea for you. But in the corporate life, in the corporate world, majority of the solutions that you see, especially in IT, follow the AI or ML language that is specifically based out of statistics. And it's very important to get the basics right. And the topic for today, which is normal distribution, is extremely important as a basic subject for anything that you want to do in data analytics in the future. So let me just start with a very easy presentation of what normal distribution is. I'm going to base the topic normal distribution in a set of 3 to 4 videos where I run you through what the concept of normal distribution is, to what is the formula, to solving sums. So it's going to be a very easy progression. If you watch 3 or 4 videos, you'll get the whole topic. And it's important to distinguish between two types of normal distribution, which is one only for population and the other one is where sampling comes in play. For now, we're going to discuss only situations where the population is concerned. So let's get started and let me just explain what normal distribution is today. So let me just start discussing what a normal distribution is. A normal distribution stems from the word normal, right? Um, if I were to define normal, it just means anything which is not out of the ordinary, right? This is a pretty basic definition of normal. And I'm going to explain through examples why normal distribution follows this definition. So imagine the first example. Imagine you're in a classroom and you're the teacher. You just gave class 9 students their history exam papers, and you're checking their exams and you find out that out of a marks out of a total number of marks of 100, you find that approximately 20 students have scored below 20 marks. So these people are not up to par with the requirements of the class. Assuming that 20 is the passing marks, these people have not even scored the bare minimum and have definitely failed, right? So uh, a number of 20 students have failed the exam. Similarly, what you'll find is a similar number of students have actually done extremely well. They've scored amongst the highest. That is, their marks range from 80 to 100. So they've done actually pretty well with the course. And it's pretty important to observe the fact that in normal life, you'll find in history there are people who are interested and there are people who are not interested in history. And the most important of them is people who are average. I mean, they are interested, not interested, and they score average marks, right? They'll fall in this area. These are people who have scored average marks, that their marks range from 20 to 80. And they've not done bad, but they've not done the best either, right? They've not done the worst either. So if I were to draw a curve to explain this kind of phenomena, it would look very much like a bell-shaped curve, like a bell-shaped curve, right? Let me just highlight that so it looks better and it's easy to comprehend. But well, in statistics, anything which is used to describe a normal phenomenon will have a curve like this. So anything which is to be explained to be normal is explained in a bell-shaped curve. Now let me give you a different example, right? If you talk about sports, if you talk about sports, right? Let me give you a different example. Assuming you're someone who enjoys sports, right? So let's talk about the sport of football. Football. I apologize for my handwriting. I know it's not the best, but in order to understand the example, it should suffice. In football, you come across very good strikers like Messi or Ronaldo, and you'll come across very bad strikers like Nicholas Bentner. And I have nothing against Nicholas Bentner, but he has been a striker who kind of misses every goal opportunity that is there. So if I were to kind of explain this phenomenon in the form of a graph, I'll draw a graph where in the x-axis I'll write number of goals scored, and here I write number of strikers. So in football you'll find that there are strikers who are, there's a very small number of strikers who are doing very poor. I mean they're scoring less than 20 goals in their entire life, okay, for their countries. So here I'm talking about a scenario where we're talking about countries, okay, and let me just mark them with red. So if you talk about Nicholas Bentner, he scored less than 20 goals in his career. Uh-huh. So he'll fall in this category with some other strikers who've done very less for their country. If I talk about another scenario, let's talk about Messi, Ronaldo, and India's very own Sunil Chhetri. They fall in this category, right? They've scored more than 40 goals for their country, right? So Lionel Messi, Cristiano Ronaldo, and Sunil Chhetri, right? But then there's a vast majority of people who actually scored between 20 and 40 goals for the country, right? They actually are average strikers when it comes to international football. And if I were to draw a graph again, they fall in this pattern, which is again, a bell-shaped curve. So if you see any example which explains the normal situation in life, in statistics, if we were to represent that, it would follow a bell-shaped curve. And this is called a normal distribution. In the next video, we'll explain how mathematically we can define normal distribution, and just a preset to that, the formula for that is z is equal to x minus mu upon sigma. I hope you stay tuned. I hope you understood the concept of normal distribution, and best of luck for the next video. Thank you.